Okay, and the next speaker is Priya Priumal from the University of Oulu from the Fiber and Particle Research Unit. And she's talking about the sustainable mining practices, innovative technologies on tailings management. So,
thank you, Saya. Thank you for mentioning my group, though I very well also fit into Oulu Mining School, which is mentioned here in my tag, but I come from different research group I'll touch upon now during my presentation. This will be a little bit off the road of what you were listening all this time, but Saya gave a brief introduction to this topic in her keynote. I will be covering a bit about the mining industry and residues. Maybe I should skip that. You all are so familiar of this topic. And then I will go directly to the applications that we try to develop in our group using the side streams from the mining industries. And then maybe I'll try to justify how this can be, or the mining operations can be more circular and sustainable by also adding this kind of solutions in your projects. This is the slide that I think I should skip. You are not the audience that I have to convince that mining is inevitable for whatever we are talking about sustainability, so I'll skip this one. The main motivation of the research that we are doing in the group that I come from is this statistics. This is the recent one that I could get in the Finnish statistical data. This is just covering the situation in Finland. I think most of you agree the country is small with a bit of relatively smaller population as well, and of course we are very active in mining and quarrying businesses, so the highest number goes to this criteria, which is not a surprise. But then also if you come to the construction sector, it's also like a high amount of waste that has been generated and kept in landfills. So this is considered as waste just because we didn't find any solution yet. Like it was also mentioned by my earlier speakers, this terminology called waste is changing dynamically because of our needs, and also then we are emphasizing on this circular material flow. So our group is working on giving them a different perspective and changing these materials from being waste to be resource. This is the group that I come from, and we are like 50 plus researchers and mostly working on the external fundings from EU and national projects. Like you see to the right side, it shows like what are the works that we do. So we start from characterizing the material for any type of research that has been also mentioned by other speakers. First thing is to understand what you have in your hand, so clearly understanding what is the residues that we are getting, and then going for the next step to know like what kind of processing could be done on this material economically and also feasibly if it could be upscaled to industrial level. So we always have this kind of discussion in the early stage after we have this material, what type of processing could be feasible for particular material, so we can end up in some applications that could be potentially useful for some other industries. So we can recommend these materials as a secondary raw materials for other applications. Mainly we focus on construction applications. So you see here it's aggregates, which is nothing but the filler material in concrete production, mortars or like small scale applications in construction industry, maybe a pavement block or some other applications like that. And concrete is for your structural application. You see all the buildings that is made of concrete. And we also work on stabilizing these tailings. Mostly we don't encourage it in most of our projects just to stop with stabilization, but to go for some application. This is the group that I'm leading. So in my group we are focusing mainly on mining side streams. So, which also includes then mining and urban mining. So here urban mining, because these are materials that comes from the urban area like recycled concrete or the municipal solid waste, or also the excavation material that comes from the construction industry itself. And then it covers the same procedure that I explained in the big picture about the treatment methods and applications, but we also look into how these products. Like when you are giving some new product to the community, they are going to question you like how it is going to affect my comfort. So we also check like how this is going to affect the indoor air quality or thermal comfort or other properties, so on. This is also important to put them in the market, right? Because there are policies that's going to question you about the durability of these new products and several things. So this is also part of our work. This is the group of people who are helping me to do this work. We all talk about sustainability, but I always start my presentation with a definition for sustainability because it's always good to remind ourselves like what we are talking about sustainability. So it's like it's the way that we have to lead our life to be comfortable in the present generation, but without spoiling the possibilities to lead a better life for our future generation, right? So we might or we can do it in several ways, but this lies in 3 different pillars like economic, environmental and societal pillars. And I focus on construction materials because mainly these materials are natural resources in construction industries. So it's a very good match between these residues that is generated in different industries, especially mining industry because of the huge volume availability, and there is a need from the construction industry in a huge volume for their application. So that's like a match made in heaven. So we want to focus on that and give a solution for the construction industry for their needs for the material. These are some of the projects that has been already handled in this research group. With that, I will go to the next one, which is more interesting for you to understand the applications that we develop. One of them, the first of its kind, is like alkali activation technology, which is nothing but that we add some alkalis to these sources of residues, and that helps this material to behave in a way similar to a cement in the construction industry. So cement is nothing but a glue that is holding this filler materials together, so you have this kind of structures, or you can mold it to different structures, whatever shape or size you want that to be. And in this case, you need to have silica and alumina in your system in a particular mineralogical form, like an amorphous form. So it should not be crystalline. So then you can use it to form an alkali activated material or building blocks. So how we end up in the alkali activation technology is also a good story to convey. GeoSelf was the first project that we started doing with a mining company. So the request from the mining company was like, oh, we have so much of this tailings and it has a lot of heavy metals. We want to just dump it somewhere like in the tailings pond, of course, but we should make sure that it's not leaching any heavy metals later on. So this was the request from the company, and we started working on by like adding some chemicals, so we know like this is going to stabilize the material when it is dumped. But naturally, when we are doing such works, we used to make this kind of tablets or kind of small cylinders, and then we do try to test the strength of these materials. And to our surprise, the strength of the material is not that bad, which could be used as a building blocks. So which is why we then suggested to the mining company, why should you just dump this material? Maybe we could suggest some application. So this was the first project that was started for the alkali activation technology, which was initially for the stabilization method. Then it went into some applications. And because of adding this alkali materials and to form this kind of blocks, of course it helped in stabilizing some of the heavy metals because we could form a yttringite structure. Yttringite is like a floor-like mineral, so it could physically hold your heavy metals into its structure and it don't let it leach out. So this is how this is happening in the alkali activation technology to stabilize your heavy metals within the system. And when it goes to some kind of blocks, it's still more like confined within that block element. That's more on the initial part of the technology. Then we developed further and we tried to pre-treat the tailings before we do the alkali activation. So we could also improve the reactivity of the material. Here the reactivity is not leaching of heavy metals, but how well it could react in the early stage of the cementing process, so it gives better strength in the construction applications. So the reactivity is positive here. So we started working on different types of pre-treatment like thermal activation, mechanical activation. Maybe Saya mentioned that it's not really a great idea to do mechanical or any type of pre-treatment because it's adding to the emissions or adding to the cost and everything. But when you consider to the cement industry, which is already like using like 1400 degrees of temperature to produce the cement that we are already using now, so if even we could reduce some amount of that energy, we are actually making some progress in the other side, in the cement field. So we were still thinking of like if we could match the performance of this material similar to what it is available as cement in market, then it's gonna be fine to some extent. Of course, we have to keep working on reducing this energy need for the pre-treatments. And after pre-treatment, again we will go for this alkali activation method. Sometimes we also go for different other type of binder systems or the cement systems, which I will touch upon in later slides. When you consider alkali activation technology, like I was saying, not all of them or not all the tailings gonna work in this system, right? You see 3 different types of tailings from different sources. We tried similar pre-treatment methods like thermal pre-treatment, but obviously we know that this is going to happen, but this is for showing that this is how the material is. We did it for the research purpose. So you see kaolinite will become metakaolin when it is calcined at 750, but if you are going to calcine further in higher temperature, then it's going to recrystallize and it don't react or it don't behave as a cement. So which is why the kaolinite is not good in 900 degrees Celsius. So when it comes to lithium, it's mostly like feldspar quartz. So I cannot do anything even if I am thermally treating at 900 because it's not going to melt below 1000 degrees, so it's not working at all. So this is an example to show like how each mine tailings has to be defined and given as like an actual solution for them based on their properties or the material behavior. This is how we do the mechanochemical treatment. This both are silicate tailings, but I want to just show how a clustering kind of behavior is happening in one type of tailing, and in other it's really a very good distribution. So we also go in depth to analyze how this is behaving in the microstructural level to understand how the binding is going to happen in the cements, right? In the mechanochemical activation, this is an example how the amorphous content is affecting the strength. So when we are increasing the grinding time, of course it reduces the size of the tailings particle, but also then it increases the amorphous content. That is the crystalline part is destroyed or damaged because of the milling, and then it improves or increases the amorphous content, which is also then seen in the increase of compressive strength of our construction blocks. Until now I was describing about the alkali activation technology, but when we talk about commercialization, it may be gonna bit difficult if we talk about alkali activation, which is not really accepted by policies and legislation in the construction world. So we were thinking of like how we can do it much faster. That then this is the supplementary cementitious material where we are not 100% replacing the cement, but we are going for like partial replacement, like 20 to 30% of the actual available cement is replaced with this pre-treated tailings. And we did a study on that. Here we also use 2 different types of mill, like ball mill and also then vibratory disc mill. These are all like laboratory studies. We didn't go for like bigger scale one. But we could understand that some of our tailings are really potential enough to go for market with this kind of just mechanical activation by milling them. They have properties that matches to this commercially available cements. So this is to convince the industrial people that okay, this has a potential, we should look into it. These are all on the binder material, but we are also looking for high volume application, because when you consider about the concrete, 30% of the concrete is binder, but the remaining 70% is aggregate. So we want to also focus on using some of the mine tailings in aggregate application. Here what we have done is we do granulation of this material, and after granulation, to improve strength, normally we put them in high temperature. If you have heard about this LECA granules, lightweight granules, they use high temperature to make such a lightweight granules. And in this case what we have done is we identified that this material have some calcium and magnesium content, so we just put them in the carbonation chamber to understand whether we can capture some CO2 and will that impact the strength of this material, and it does. So we thought like we will avoid the high temperature treatment after granulation, and we put them just in the carbonation chamber, and it improved the strength. And the main application that we are planning with this is this kind of hybrid blocks, and that can be used in the lightweight construction. This is not yet published. The other works that I am describing is already published, and you can go and have a read. And the slides are available later on, so you will get that as well. And not all, like earlier I said that the lithium tailings were not working good as a binder material, so we wanted to check what could be the other application. In that then we identified this quartz feldspar is a key ingredient for ceramic industry, so we just were lagging some amount of clay there. So we started adding like a bit of kaolin, and then working on producing some ceramics out of it, and it worked wonder. It was very good, and we started this new applications with tailings that has quartz feldspar, mostly the lithium tailings. And we are not just doing it in labs, we also have, or we had some projects earlier that was about having pilots in the mine site, and one of them is about cover layer. So we just used one of our composition to make a cover layer in a mine site. In this, the specific need was to make the cover layer impermeable, but with our composition it was not already impermeable, so we have to make a bit more advanced composition, which I will explain in the next slide. For the underground backfill, our existing mix design is already very good because it needs only 2 to 5 MPa of compressive strength, so we already have achieved in our previous works. For this cover layer, what we did is we did a bit of nano grinding of our material, so we then incorporated smaller particles, and then it improved the impermeability. Yep. I will cover, these are works that has been done earlier and it is in the publication. I will also cover a little bit about the existing projects. Exceed, which I am working also together with Oulu Mining School, where we are covering 4 different lithium mining industrial cases, and we are trying to develop this kind of solutions, mostly focusing on high temperature ceramic applications, alkali activated binders, and the supplementary cements, like I said, for the partial replacement, together with the industry in Finland called Betoler. And for ceramics we have Wienerberger from Belgium, who is going to make a pilot study on this composition. And we are also working on the lightweight aggregates with the University of Lorraine. And for the resource, which is a recent project, almost like 6 months before it started, which is on rare earth element from Norway, and here the tailings are carbonates, so we want to develop some different type of system. So not all the time we will go for the same type of binder system. When it is carbonates, it doesn't have alumina or silica for the like regular binding system. So I was then proposing this limestone calcined clay system, which is already established, but I want to check like how this carbonates from the tailings will gonna fit into this system. So this will be developed in the future years. And we also work on stabilizing sulfidic tailings in very basic level. So we go to the synchrotron to understand like how this is working, how the mechanism of these things are happening. So we have better knowledge for our future works. And this is more on the same like granulation and carbonation work. I'm just rushing because I see 1 minute more. So key takeaways from my presentation could be like mining is inevitable. I think I don't have to convince so much for this crowd for technology and green transition. So it's really possible to create a sustainable mining environment. So you saw a bit of little bit of some of knowledge that we have, and I think my next speaker, Paivi, could also touch upon on these topics. Then proper mine planning will help in circular material flow. An example, Caliber, they are working with us for the past 10 years for using their tailings in different applications, and they are going to just start the mining soon. And let's take one step at a time. So let's start with the tailings-based solution in mine environment. So thank you.
Great presentations. Questions? One quick one. Yeah, please.
Okay. Hello, thank you very much for a very good presentation. I was just curious about the blocks that you made with the tailings as you showed. How comparable is it to the traditional blocks that we have? Or do they have to do some adjustments if you are going to use it in the light method?
We do adjust the mix design, but our main aim is to maximize the use of tailings and reduce the resources from the nature for the construction.
Okay,
So
but
we
the
do
properties are
adjust the mix
comparable, yeah?
design. Yeah.
Okay.
Thank you. I think that we should move on now, and you can
Sure.
ask more
Thank you.
questions from
Yeah.
Priya during the lunch break. Thank you so much.